9 DevOps metrics you should be tracking. Ever feel like your DevOps process is a black box where you toss in code and hope for the best? You're not alone. The key to demystifying that black box and avoiding 3 a.m. fire drills is tracking the right metrics. Today, we're going to chat about DevOps metrics you should be tracking, starting with the famous DORA metrics, and then some other game changers. By the end, you'll know what each metric is, why it matters, and how it can help your team deliver better software faster. Let's dive in. Deployment frequency, DORA. Deployment frequency is exactly what it sounds like. How often you deploy code to production, think of it as like how often you hit ship it on new features. High-performing teams deploy on demand, often multiple times a day. If that sounds crazy, consider that smaller, frequent releases carry less risk and give users value sooner. If your team deploys only once a week, it might indicate heavy processes or fear of breaking things. Big releases carry so many changes that can impact your product or introduce new bugs. Therefore, you should break down big releases into smaller releases so you can better test the impact of each release before adding new stuff. 2. Lead time for changes, DORA. Lead time for changes measures how long it takes a code change to go from committed to running in production. In other words, how long does it take for a developer to finish writing code to deliver that feature to the end user? High-performing teams typically measure this in hours, whereas low-performing might take weeks or even months. Imagine ordering a package online. Lead time is like the shipping time. Faster lead times means features fixes or improvement reach customers quickly. Why does it matter? A short lead time lets you respond to market changes or bugs faster, keeping users happy. If your lead time is long, it might be a sign of process bottlenecks, maybe waiting on approval or test that takes forever. 3. Change failure rate, DORA. Change failure rate, CFR, is a percentage of deployments that results in a failure, meaning something went wrong that required a hotfix, rollback, or patch. If 1 in 5 deployments causes midnight pager alarms, that's a 20% change failure rate, and probably a lot of tired engineers. Elite teams keep this failure rate low, often in the single digits. For example, industry research found high performers hover around 0 to 15% change failure rate. Why should you track it? Because it tells you about quality and stability. A high change failure rate could indicate insufficient testing, overly large changes, or just rushing things. Keep improving testing using small incremental changes and doing postmortems to learn from failures. Over time, you want deployments to feel routine, not like a game of Russian roulette. Mean time to recovery, MTTR. Despite our best efforts, failures will happen. Mean time to recovery, MTTR, measures how quickly you bounce back when an incident occurs. In other words, if your deployment does cause an outage or your system crashes, how long until things are up and running again? High-performing teams recover super fast, usually under an hour on average. Slower teams might take days or even a week to recover from a bad release. Whenever an incident occurs, make sure to adopt a blameless culture and aim for continuous improvement because every failure is an opportunity to improve things. You can track the mean time to recovery metric using DevStats to see if your incident response is improving. If last year an outage meant hours of chaos and now you can restore service in 30 minutes, that's a huge win for reliability. 5. Cycle time. Now beyond DORA metrics, let's look at some other important metrics. Cycle time measures the total time from when work starts on a task to when it's completed and delivered. This is a bit broader than lead time for changes. Think of cycle time as the journey of a feature from the moment a developer says, "I'm on it," to the moment users see it. It often includes coding, code review, testing, and deployment. If lead time, DORA, is like shipping time, cycle time is like the entire order fulfillment process, including packing and transit. Shorter cycle times indicate an efficient workflow with minimal wait states. For example, if your average cycle time is 3 days, your team is likely moving at a good pace. Whereas an average of 30 days might mean work is sitting idle somewhere By breaking down cycle time in phases, coding, reviewing, deploying, etc., you can pinpoint where the slowdowns are. DevStats allows you to analyze cycle time per phase, squad, team member, or Git branch. This gives you detailed insights onto finding potential bottlenecks. 6. Mean time to detect MTTD. Mean time to detect is all about how quickly you notice there's a problem. It measures the time between an issue occurring in your system and the moments your team discovers it. Imagine a bug hits your website at midnight. Do you find out at 12:05 a.m. because your monitoring pager went off? Or at 8 a.m. when a user tweets, "Hey, the site is down"? That gap is MTTD. A shorter MTTD is critical because you can fix what you don't know about. This metric reflects the effectiveness of your monitoring and alerting. In real-world terms, think of a smoke detector in your house. If it goes off immediately, where there's smoke, you catch the fire early. If you have no smoke detector, you might only notice the fire once your neighbor bangs on the door. To improve MTTD, teams invest in good logging, automated alerts, and even anomaly detection tools that flag unusual patterns. 7. Test coverage. Quality assurance time. Test coverage is a percentage of your code that's covered by automated tests. For example, 80% coverage means 80% of your code paths are tested by at least one test. This metric shows how much of your code base is under the watchful eye of tests. High test coverage is generally a good sign. It's like having more of your bases covered when it comes to catching bugs. It doesn't guarantee bug-free code, but it greatly reduces the chances that a silly mistake slips through the production. Why track test coverage? It helps you gauge the safety net you have for making changes. If your coverage is, say, below 50%, you know that any change might break something untested. If it's 90%, you can refactor with more confidence. 8. Mean time between failures. Mean time between failure is an oldie but a goodie. It tells you the average time your system runs before encountering a failure. Essentially, it measures reliability by looking at this interval between incidents. For instance, if on average your service crashes on every 10 days, your MTBF is 10 days. If it only crashes once a year, MTBF is 1 year. This metric is like the flip side of mean time to recovery. MTTR is how quickly you recover from something breaks. Mean time between failure is how often things break in the first place. A longer MTBF is obviously what we want. It means failures are few and far between. Uptime availability. This one comes more from the operation side of DevOps. Uptime is the percentage of time your system or service is operational and available. For example, 99.9% uptime roughly means your service was down for at most 7 hours in a year. Uptime is a straight-to-the-point metric indicating reliability and performance from the end-user perspective. If your website or API is mission-critical, you might have an uptime SLA, service level agreement, to meet, like 99.99%. It's called the famous 4 nines of uptime. So, why track uptime? Well, users don't care if you deploy 10 times a day or have 90% test coverage. If the service is down when they need it, therefore, uptime is king for user experience. Now, for the summary. There you have it, 9 DevOps metrics that give you a 360 view of how your team is doing. From the speed of delivery to quality and stability, and everything in between, like how fast you detect and fix issues. These metrics help shine a light on what's working and what's not. The goal isn't to obsess over numbers or create a dashboard just for bragging rights. The goal is to use data to improve your processes and outcomes continuously. For example, you might notice your deployment frequency is low. Maybe you can automate some manual steps. Or your MTTR is creeping up. Perhaps invest in a better tooling. In the end, DevOps is all about delivering value quickly and reliably. Metrics give you the feedback loop to get better over time. Thanks for hanging out and talking metrics with me. Keep measuring, keep improving, and happy deploying.